Hello everybody, let's solve day 12 of Advent of Code. I have already pre-read the description of the problem because I'm starting late today, so I have some idea how I will solve it, hopefully. So the idea of today's day garden groups is that we are given a map of kind of garden arrangements, and our goal is to figure out what are the areas and perimeters of each of those arrangements on the map. And those arrangements on our garden are marked with letters that describe the kind of different plants that are planted there. And each area is a polygon which contains the letters. And our goal is to figure out what's the area of each of the polygons and also what is the perimeter, basically the length of, if we added up the length of the edges of the polygon, what would be the total? And then our goal is to multiply those together and sum it all up. So here's an example of how it works. So for example, R here is kind of this shape, and we are calculating the area, which is 12, then 18 edges on the on its border, and then we multiply to get 216 and so on. The question is, I'm not completely sure about if there are duplicates, if it counts as separate areas or one common area. So let's check that. So this contains 5 regions. Okay. Right. So for now, I will assume it's the same character will be counted as a single region, but we'll see if that is the case. So let's try to implement this. So I will take the sample input here, and what I will do is that I will be kind of going from each of the points on the map and try to float fill from that point to see the area with the same character. And then when I found that area, I will also keep track of what are the edges of each of the points themselves. So if for this one, it has an edge on the bottom, which is like, what are the non-R neighbors of that point, for example. So if we have a point with a letter R, we check if how many of its neighbors are not R. The same here. Not R is kind of this V and this like out of bounds area. And when we calculate the perimeter, it's basically the number of edges which are not neighboring the same character for each of the points in the shape. So hopefully that should be enough. So I will do lines equals input reader read all lines async, and await. Then we have private int width and private height, and then we do width and height will be, come on. Sometimes Copilot is very chatty, and sometimes when you need it, it's just not cooperating enough. So, okay, so we now do for x less than width and for y less than height, and I'll actually do it this way to make it more memory cache friendly. So this should be better. And now we'll just read inside of a map. So I will have a private car map, and that's going to be initialized to new with height. And then we will actually it's gonna be more friendly if we do it the other way around, right? So it's gonna be this. So like that, I will do it with the braces, and then we just read in the point. So map xy lines yx. That should be right. So now we have the map read in, and we will go. You have some kind of private hash set point assigned. So we'll be assigning each of the points some integer group that will be its will mark the shape that it's in. So it's gonna be 0, then 1, 2, and so on. So we'll be, for each of the letters we will have a separate group. And by default nothing is assigned for, so we will go and for x, y, if assigned contains x, y, and we will be returned with area, perimeter, and we'll have some kind of running total. So total probably is enough to be an int total. It's going to be initially 0, and total will be area times perimeter. So this is enough, and now find group. So this will be our flood fill algorithm. So we private int area, int perimeter, find group for int x. Well, let's do point x starting point, and then so we'll be calculating the perimeter, so total perimeter 0, and hash set it will be shape points. So this will be tracking the points that are inside, and then at the end we will do this to get the final result. And now we will enqueue, we'll have a queue of points, yes, and we will enqueue the starting point. And while the queue is not empty, we will be going through the queue and dequeuing and marking the points as visited and so on. So visited, so assigned at queue. Oh, well, point the queue. We'll assign that point, and then we will. Well, let's call it visited for now. We don't have to assign it to anything. So visited. So we will be returning. So this is the point itself, xy, and we will be adding it to visited. And now, based on the, we'll add it to the shape points, and then what we will do is get the number of edges. So for each neighbor in directions without diagonals. So we don't care about diagonals there. Yes, we don't. So based on the diagonals, we will do neighbor or direction. Neighbor is point plus direction. So if neighbor, and we'll have a method like private bool is in bounds, will be point and this is the logic that I wanted exactly. So if the is in bounds neighbor, if it's not in bounds, okay, if it is in bounds, and if it's not in bounds, we'll add it as additional parameter point. If it is in bounds, so we will take the type and we'll take the type of the plant that's on that point, and if the type equals map point x point y, we will add it, and if it's not visited, then we add it to our queue to be processed later. And if it's not the same type, we will add that point to the parameter, to our parameter. So this way this will count the parameter, and this will be adding the points to the shape itself. And overall, when this finishes, we should have the proper area and parameter so that we can finally return the total toString. So I kind of cruised through this. I'm not sure if it's really correct, so we'll have to verify it for some of the first inputs, but it does make sense in my head at least. Oh, right, I didn't put a throw not implemented exception, and actually it's day 12 already. So day 12, yes, that's correct. So let's see what happens. So I will take the day 12 and run this data. So the initial one is 12 times 54. That's definitely more than I would prefer. There. Yes. So what is the problem? So why is it that many points? I am primarily counting the parameter incorrectly. So the shape size is correct, but the parameter is too huge. If it's the same, let me enqueue and don't increase parameter. If it's not the same, we are counting that. We're also counting it for non-neighbor. So without diagonals, that is correct. So are we counting it twice? Somehow. Okay, let's actually do it this way. We can verify our logic by going through the individual points. So I will let it run here, and let's see how many we end up with the first one. So the first point that we add in is 0, 0. So for the first point, we should have 2 as the total parameter, yes. So next one is going to be point, so it's going to be this one. This should have a parameter of 1, 2 as well. And it's 5. So there is something incorrect in that logic. Let's try again. So what is the problem there? So initial one is 2. Then now the next point is 0, 1. And now it's fine. Without diagonals, we are going to here. And the neighbor is in bounds. And its type is V. That is correct. And so it is not part of the shape, and we add to that parameter. So that's first one. What happened there? Did I misclick? Huh. What did happen? Wait, I did something wrong here. So once more. For the first one, we get 2. Now, for next point, we get direction +1. So this is the neighbor here. So this is the V. The next neighbor is x1, y1. So this would be R. So we should keep the same parameter for this one. And the neighbor is yes, so that's good. Next neighbor is -1, y1. -1, y1, so that's to this area. So that's gonna be total parameter 4. And we are done there. So that's so far correct. So 1, 1. We are processing 1, 1. So are we accidentally adding them twice, or? No, that's unlikely. We are counting the ships correctly. So what is the problem? For 0.11, we should end up with 4. That is correct. Or it actually should have 1. That is, something is going on there. This is wrong for each, right? This one. So we should have 5 now. The next point is 1, 1. 1, 1 again. How did you add? That is odd. Yeah, okay, so we are somehow enqueuing it multiple times, it seems. So that would be a problem. Data, let's see if I put it there and do test data in. So we have in queue initial 0, 1, 1, 0. 0, 1, 0, 1, 1. 2, 0. 2, 1. But no, it seems okay. So what is going on? Okay, we should probably debug this a little bit more. So okay, what I will do is point parameter gonna be equal to 0, and I will be doing point parameter plus 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 plus, and finally total parameter plus point parameter. And here I will do debug write line, and I will write as parameter this. Okay, so let's see what happens if I run this for the first shape. Test data. And the output against it. So 0, 0. One, 2. So 0, 0 should have parameter of 2. 0, 1, 0 should have parameter of 1. 2, 0 should have parameter of 1. 3, 0 should have parameter of 2. Oh, maybe this inner ones? No, that should be okay. So this is 0, 0. So 3, 3, 3, 3. But no, you can see here, we are getting the same ones multiple times. So yes, of course. That's exactly it. I need to make sure that I edit to visit it before I enqueue it, because I can accidentally enqueue things multiple times. So that's logical. Yeah, because if I'm processing it as a queue, it's possible that from 2 points I enqueue the same neighbor. So now we should be better. This data, and the first one, 18, 8, and 12. That's better. Okay, so 19, 30. And that is correct. Okay, so that was a blunder. Seems like some ASCII art thing. Not sure what it is, but it's pretty nice. So let's save the input, and let's hope that this will work. So it's running. I should probably remove the debug write lines, because those are slowing things down. But this is the result, hopefully. Also correct one. So let's see what happens. And that is correct. Okay, so we have the first part of the problem done. Now let's go to the second part. In the second part, we are qualifying for bulk discount, and we need to now, instead of perimeter, calculate the number of sides of each region. And each straight section of fence counts as a side regardless how long it is. So now this has 4 sides. We no longer count as 10, but just 1, 2, 3, 4. B has also 4 sides. This is 1, 2, 3, 4, 5, 6, 7, 8. And this is 4, and this is also 4. So we now count kind of the edges of the shape, not individual points or individual coordinates. So now it's becoming a little bit more interesting, because now this E shape has kind of 12 sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the idea here would be to use a rolling window. I'm not sure if that's how it's called in English, but in Czech, the algorithmic approach is something called a rolling window, where you kind of move a window across the area, and then on each of the points where the window stops, you check something. So in this case, what I would do is go for each vertical location between points. I would check for the same letter, and check how many occurrences of that letter are next to each other. And when there is a gap, then we have one side, it breaks the side. So every time there is a continuous line of the same letter, that's a side, and then when there is a break or space, then we have we like end that space and end that side and add a new one. So hopefully it makes at least a little bit of sense, but I will try to now implement it this way. So the code that calculates the area is the same, so that's okay, but we'll need to calculate the size. So we'll have is private dictionary car int areas. We're adding areas. So if areas contains key map, let's just check here. So 2 and it's 4 by 4, 16. So 32, yes. So it counts as a yeah. So if we have two shapes of, it's a total area, so it's sum of it times 4. Is it the same thing? No, each of the shapes should count separately. So that is right. So in this case, we need to count. You cannot count it as 8, area of 8 times 8, because that would be 8 sides, but it's actually 4 by 4 plus 4 by 4. So you cannot really take it this way. We need to mark each area as a separate thing. So private int areas, and now area IDs, or no, areas. You can do areas, and here or shapes. Let's do shapes. So this will be the shapes. I will be doing a shapes equals this, and now I'll do private int shape ID. So initially it's gonna be 0, and then we'll always increase the shape ID. So shape ID. So it will be this way. So now each of the points we will assign to the shape itself. So we no longer have to track the visited points. We can just assign it to the shape ID. So we'll assign shapes starting point X, starting point Y to the shape. So shape ID. So this becomes the shape. And now checking for visitors is just checking if shapes neighbor X neighbor Y equals 0. So far it's not assigned to any shape. Then we add it to our new shape, and then enqueue. So that's it. Now here we just also check if shapes xy equals 0. Then we try to find a group from there, and then we add areas. So the areas will be there, and there's going to be a dictionary of int to int shape areas, and this will be a dictionary that will will store the area for each of the shapes. So I will do shape areas, areas shapes xy equals the area that we are given. And now we need to calculate the sides themselves. So for int x equals 0, x less than width x. So that's going to be the horizontals, like the vertical lines, and then the horizontal lines. And now, so for each of the horizontal lines, we will be checking the top of that line and the bottom of that line. So for x, so that means that we are going from the left to the right. So we will be checking from the left to the right. So we have the vertical line at that location. And then we will go from the top to the bottom. So to the top to the bottom. And then we will count side. So initially we have last shape d equals 0. So if shapes at x, y, so we'll have to check it for both the left of the shape and the right of the shape. So we'll be checking if, let me think about that. Yes. So as we move to the right, we need to zero. So it's going to be the x will give us the left, put the sweep line to the left of the character that we are checking, but we will have to go to with less than or equal to with. And now what we will be checking if to the left of us is the same character as we are on, then that's not a side, right? So we'll continue to the left. Oh, sorry, I have to think that through a little bit. So will be, so if yeah, okay, yeah, we need the last shape ID. If last shape ID is not equal to shapes x, y, so we are at the end of a we are changing the shape that we are on, then we add the side if the shape was not if it was not last shape ID wasn't a 0. So add a shape, so side. We'll have some kind of tracking for the shapes side, shape sides. And initially we'll initialize it for all the shapes for each shape in shape areas keys. We'll do shape sides shape equals 0. So just to initialize it. So we will do shape sides for last shape ID e plus plus, and last shape ID equals shape xy. Right, so rather like this. So last shape ID. So now we are on a shape, and we need to check if to the left of us is not the same shape as we are on. So if is in bounds, if it's not in bounds, so shape, so map, no, x minus 1, y, if it's not in bounds, or if the point left to us is not in bounds, or it's map shapes x minus 1 y equals last shape ID. In both of these, if it's not, okay, so it's not if it's not in bounds, or if it's not equal, then we just continue to the next part without adding up the shape. And otherwise, if it's in bounds and it's the same thing, then we add the shape side as well. And yes, this should be like this. So that's basically partially the logic, but we need to also make sure to count for the point where we're here, where we need to take the +1 of that instead. So let's see. Actually, yeah, what I can do is to do it like this. And actually, finally, we also have to side length 0. Side length plus plus 0, assign 0, and we add it up. Okay, so that's that. And if we end up with side length not equal to 0, we also add to the last shape ID at the end of the column. But we need to do this for direction in point, and it's gonna be well, that's not what I wanted. So 1 0 and minus 1 0. So for each of those directions we will be doing this, and for each direction, and the direction we will be using here. So neighbor xy plus direction. So this will be the neighbor that we are checking. So neighbor.x, neighbor.y. Right. So now this is for the vertical lines, and we need to do this same thing for horizontal lines. So I'll just copy paste. It's not ideal, but let's hope it ends up working. So less than height and y plus plus x width x, and now this is the same, but we need to go with +1 here, -1 here. Yeah, okay, so something like this. I'm not completely sure about this logic. I need to make sure that I validate it properly. So so when this finishes, we'll have for each shape in shaper as keys, we'll do total plus equals shape size times shape areas shape, and that would be the result. But I am not sure, and it's very likely this is not correct yet. So we'll have to validate that code and maybe fix it a little bit. So for part 2, with the star data, we will have, yes, so so shape size definitely way too much. So the areas are okay, but shape size are not okay. So let's debug for the first area, right? So for this one, we start with shape 1. So that's gonna be RR. So we should have one side there. Neighbor. How does it jump there? Yeah, debugging is kind of weird here. But the side length XY. Let's see, once more. I misdebugged here. Okay, so we continue here. We have this guy in bounds. We go here. So last shape ID plus y. Side length. Oh, okay, so we are adding else if side length not equal to 0. XY. So that's the first fix, but I'll need to replicate it into the second part as well. So actually, let's do it now so I don't forget. But it is not yet over, I think, because this will be still too much. Why is it so broken? Seems like my breakpoints are not hit correctly. So total shape sides, 10 shape sides. 10. Oh, that's not bad. 10, 10, 6, 16, 22. 16, 22. Like the numbers are not terrible, but now the result is way too high. So how many shapes do we have? We have 11. 3, 4, 5, 6, 7, 8. So it is okay. But there's some incorrect value there. So what I will do is to output that map. So, or actually let's do this. I will output debug right line and do like that. Maybe let's do car names. So when we create a new shape, we will do shape names, shape ID equals map starting point. So that just for debugging purposes, I have a way to know what the shape name is. So I do shape names plus equals plus shape sides shape plus shapes plus shape sides shape areas of shape. Okay, so this is just a debugging helper. We'll see what is the output here. Right, so what we have is for R we have 10 times 12. For I we have 4 times 4. C is 22 times 14. V is 13 times 10. M is 5 times 6. I. Okay, so we have 2 I's there. That is weird. How can there be 2 I's with also a different result? Whew. Okay. What is happening? Okay, oh, right. This is actually there. Oh, that was weird. So, yeah, I'm not outputting the right total, but that doesn't matter. As long as the numbers are correct, it should be fine. So, but the initial, oh, right. Okay, that's a blunder. So I was keeping the total from before, so the results couldn't be correct. So that's another oversight from my side, but this is actually a correct result. So not too bad, but I'm afraid this might be more complicated. So I will try against the actual input file. So this is the result. And that is correct. Okay. Oh, right. So this one was definitely the hardest, at least for me so far. I don't really like the solution that I have right now. This nested thing happening twice the same way, basically, is not cool. So I would love to kind of refactor it a little bit here. So how do I do that? I could do something like, so first off, move this to count sides method. So this would just count the sides, so I just refactor it as a separate method. But the whole meat of the thing I could refactor as some kind of private int last shape ID and side length, sides, and the input would be side length last shape ID side length, or actually it's initially 0, right? So essentially this whole thing could be hidden in here, as long as I put in also the current point and point direction. Neighbor direction. So this would be the current point X, current point Y, and you would do actually, yes, we need to also have the side length. So this is the side length, then we have current point X, current point Y, and then we do current point plus neighbor direction. And this would be return, and this we need to return last shape ID and side length. So that's that. And if we return here, then we return last shape ID side length. So that would be a track sides, and we would put it there. Something like this. And we set last shape D side length equals track sides. Well, it's not that much easier to read, but it kind of deduplicates the logic that was there. So at least in some way, it makes it simpler. So I'm thinking actually a good way to refactor it would be to instead of going to doing the for loops, I could have a source point and just go in specific direction and calculate the perpendicular one, but overall it's going to be the same kind of result, and I hope I didn't break it with these changes, but it should be the same thing. Yes, it is. So I mean, at least a little bit more readable, but it would be probably easier to understand if I thought the solution before writing it, but as I was kind of changing it and figuring it out as I went while implementing it, the result is this a little bit unreadable mess, but at least it works, and it seems to be reliable even for the bigger input, so I'm still satisfied with that. So I hope you enjoyed this unabridged recording of day 12 of Advent of Code 2024. I will also let ChatGPT have a go at this problem. We'll see if it is able to differentiate between areas of garden. And yeah, I will see you in day 13.